Yeah, I'd love to hear that.
You have to separate them from the biggest one.
Uh-huh.
See what they are.
Okay.
So you have to, what's the word? You have to set them to the power of 2.
Okay.
5 to the power of 2 plus 12 to the power of 2.
Okay.
And then a line over the 13 to the power
Uh-huh.
of 2. So 5 will be 25.
Yep.
12 will be 144.
Mm-hmm.
And 13 will be 169.
Uh-huh.
So add 25 plus 144, which will give me 169.
Uh-huh.
That's equal to each other.
And then they're equal. What does that mean?
They're right triangle.
Very good. If it satisfies the Pythagorean theorem, a squared plus b squared equals c squared, then it is a right triangle. Kristen, that was amazing. You did a very good job. Okay? Question, guys. Did Kristen is she just like that naturally gifted at squaring numbers?
Yeah.
No, what did she use? Calculator. You're gonna have a calculator. Use your calculator, okay? Second thing, how did she know that 13 was C? It's always the biggest number is gonna be your C value. We Gucci? Let's move on. Number 10, who got it? Who got it cute? Christian, go.
So I squared 5 and 7. Hold on. 5 and 7 are my A and B.
Okay, there are your A and your B.
And then 8 is my C because it's base number.
I love it.
And then I put 5 squared plus 7 squared equals to 8 squared.
We don't know that they're gonna be equal. I would leave that blank for now. Okay?
And then I squared 5 and 7, I got 25 plus 49, which is 74. But 8 squared is 64,
Mm-hmm.
which means 74 is greater than 64, so it's a cube.
Very good. You guys, what if that c squared side was larger than a squared plus b squared? It would be obtuse, okay? Know when you get each of the examples. How many of us got both of these before I went over it? Okay, next time we do something like this, I want 100%. Yeah, Anja. No, it's okay. You sure? Okay, today we are learning about 2 special right triangles. The first one is called a 45-45-90 triangle theorem. Guess what those 3 numbers stand for? The angles. Label that, okay? So if your angles are 45, 45, and 90, it is a special right triangle called our 45-45-90 right triangle. We do call it that, okay? I have a question for you. If our angles are 45, 45, and 90, what do you know about that triangle? It's a right triangle. It's also isosceles. Write that down. Isosceles and right. So Pete's, anytime a word problem says you are dealing with an isosceles right triangle, you automatically know it is this special right triangle. We Gucci? Those 2 are interchangeable. Isosceles right means 45, 45, 90. 45, 45, 90 means isosceles right. Why is this important? So, it's important because, do you guys agree that an isosceles triangle has 2 congruent legs? The legs of your right triangle will be the same measure. So instead of doing a squared plus b squared, they're now both what? A. Because they're going to be the same length. So a squared plus a squared will now be your hypotenuse, which is c squared. Okay? They are related by a ratio of the square root of 2. So you take one of the legs, you multiply it by the square root of 2, and that will 100% of the time be your, what is this side? Hypotenuse. Very good. Now, I do not expect you to just be like, well, where did this come from? How did you know that's the square root of 2? Why is this the ratio? Like, you probably have a bunch of questions. I'm going to prove this to you. Do you have to remember the proof for later on? Absolutely not. So if you're like completely lost by the proof, okay, don't worry about it. But I want the proof for those of you that are like, where did this come from? I want you to understand conceptually where this came from. All right, so go to the next slide, and we're going to see why this is true. Do you guys agree that the Pythagorean theorem is what? What's the equation? A squared plus b squared equals c squared. So, but for a 45, 45, 90, you guys agree it's isosceles, correct? So b is the same length as what? A. So I'm just going to write it in terms of A. So I can go back and replace b with what letter? A. So it's actually a squared plus a squared equals c squared. Do you guys agree?
Oh.
Hold on. Hold on. Question for you. What's a squared plus a squared? A to the fourth power? No. Hey, this is actually a very common mistake. Please write this down. A squared times a squared. This is a to the fourth power. I agree with that. But what is a squared plus a squared? It's 2a squared. So check it out. A squared plus a squared is going to be 2a squared equals c squared. Now, remember, we're looking for hypotenuse, right? That was what our theorem was about. It said the hypotenuse is going to be the square root of 2 times a. So how would you go about solving for c here? Nick, what would you do? No, because those are the angles, not the side lines. Yeah, Gio?
You put a square root symbol over.
Ooh, take the square root of both sides. I like that, Gio. What happens when you square root something that's squared? They cancel out. So what do I have on the right-hand side? No, on the right. Just c. Now, the square root of 2 times times a squared. Do you guys agree I can break that up? I can write it as the square root of 2 and the square root of a squared. Okay. Do you notice anything else that will cancel? A squared and?
2.
The square root. So what do we have?
2a.
The square root of 2 times a equals c. This is where this comes from. So your hypotenuse will always be the leg times the square root of 2. Okay? So this is where this formula comes from. Can I do the same thing for b? Well, b is actually the same length as a. So you can only do this for your hypotenuse. But if you wanted to do b squared plus b squared equals c squared, yes, you would get that. It's the square root of 2 times b equals c. Okay? All right. Yes, Sophia.
So this would be for the 45.
This is for the 45-45-90 theorem. Okay? All right. So let's take a look at an example. We have find the value of x. Well, first, let's identify what kind of triangle are we looking at. It's a right triangle. Very good, because this angle is 90 degrees. Let's fill that in there. We know that this is 90. Good, Ava. What else do we know about this triangle? Ooh, who said isosceles? Who said isosceles? Why is it isosceles? They have what? X and? Do you agree that x would be the same as x? So those two are congruent, correct? Okay.
Well, also, it's a right triangle, and aren't the legs of a right triangle usually congruent?
No, not all the time. In this case, they are, though. So wait, did we just say isosceles right triangle? What special triangle am I talking about? 45, 45, 90. Guys, every single time you have to write it down because this is going to be super important, okay? So the two 45 degrees, do you guys agree that they go right here and right here to make it an isosceles triangle? So we know that this is 45 degrees and this is 45 degrees. So now, guys, match up your angles with the side that's across from them. So across from this 45 is what? X. Put it below the 45. Across from the other 45 is what?
The other x.
The other x. So put it below the 45. And across from the 90 is 6, or the hypotenuse. Now remember, the two legs, right, were represented by little a's. And the hypotenuse across from the 90 is represented by what? The square root of 2 times a. This is the theorem for the 45, 45, 90. Your hypotenuse is going to be the square root of 2 times a. Now, all we have is we can't solve either one of these because there's two variables. We don't know what x is and we don't know what a is. But if we set these two equal to each other, could we solve this? Sure could. Write it out. 6 equals the square root of 2 times a. How do you solve for a? No, you don't square it. Divide by, not a. Not 2.
2x?
The square root of 2.
Oh.
Do you guys agree that the square root of 2 is being multiplied by a here? So if we divide it by the square root of 2, wouldn't they cancel? Divide by the square root of 2. Now, in your calculators, I need everyone to do this. Divide 6 by the square root of 2, and let's see what we get. Yes? Okay, see me after class. Or ask a friend. 6 divided by the square root of 2. 4.2?
Yeah, I think
4.2 is correct. So now what I just found was both of my legs, each of them have to be 4.2. Christian, what's up? Huh? You don't understand it at all? Okay, keep paying attention. We're going to do plenty more examples. Yeah.
I don't really understand what we're like solving for.
Well, in this case, we were solving for the legs. We knew the hypotenuse.
But if we know like that they're 45, 90.
Okay. Hey, I need us to write another example because I had a lot of questions on this one. So draw another right triangle. We're going to say this is 45 degrees, this is 45 degrees, this is 90 degrees. And we're going to be given that this is 7. And we're asked to find x. Okay, so do you guys agree that normally we would be like, okay, we should try to use the Pythagorean theorem if this was given to us before today? Yeah, but we don't know the length of this side, right? So what we're doing today is we're saying, okay, let's just use the property of this special right triangle. Do you guys agree this is a 45, 45, 90? So write it out, 45, 45, and 90. What's across from the 45s? They're 7s. Do you agree that they'll both be 7? Because the legs should be the same length? Very good. Now, what do I put across from the 90? X. Now, compare them, right? 7 is going to be what letter?
A.
Little a. The other 7 is going to be also little a. But x is going to be square root of 2 times a. Now, do you guys agree? We can put an equal sign here, so 7 is actually equal to a. So in this equation, where x is equal to the square root of 2 times a, I'm going to replace a with what? 7. So we're going to say x is equal to the square root of 2 times 7. Multiply it out. Let's see what we get. You guys agree the hypotenuse should be the longest side? So make sure whatever you get is larger than 7. I got 9.9. Did you round it? Mm-hmm. Take the square root of 2 and then multiply it by 7. 9.9. We can only apply this to what kind of triangles? Right triangles and?
45.
Specifically 45, 45, 90. Those have to be the angle measures. If one angle's 46 and the other one's 44, can we use it? No. Okay? It's a very special case for these right triangles. We Gucci? No? Okay, keep paying attention. All right, moving on. Oops. Close. Okay, the next special case, and this is the last one, is a 30, 60, 90. Okay? In a 30, 60, 90 triangle, the hypotenuse is twice as long as the shorter leg, and the longer leg is the square root of 3 times as long as the shorter leg. So what we do for 30, 60, 90s is we make the side opposite the 30. The side opposite the 30 degrees has to be the shortest side because that's the smallest angle. Do you guys agree with that? That has to be your little a, and then everything else follows from there. So across from the 60, it's going to be that little a times the square root of 3. So it's going to be a little bit bigger. And then across from the 90, your hypotenuse will literally be double whatever that smallest side is, whatever that smallest leg is. Okay? So in other words, I want you to write this down, 30, 60, and 90. Your 30 is your A, your 60 is your square root of 3 times A, and your 90 is your 2A. And that's how we're going to set these ones up. Okay, let's try an example. All right, example 2. Is this a 30, 60, 90 or a 45, 45, 90? How do you know it's 30, 60? There's already a 60 there. So write down 30, 60, and 90. We've got 60 here. That means that this missing angle has to be what? 30 degrees. Fill it in there just so we're all on the same page. Okay, start with the smallest side. What is going to be the smallest side? The 5, because it's opposite the 30. It's opposite the 30. 30 is the smallest angle. So in other words, that 5 is equal to A, correct? So 5 and A go together. What's opposite the 60? X. And X, or opposite the 60, should be what in regards to A? Square root of 3 times A. Very good. And then Y is across from the 90, correct? So this is going to be Y. What is Y in terms of A? 2A. So now check this out. These each become equal to each other. So we have A equals 5. So do you agree I can just substitute 5 anywhere I see A? So X is going to be square root of 3 times A. In other words, it's the square root of 3 times 5. Replace A with 5. And what do you get when you multiply the square root of 3 times 5? I got 8.7. Now, how would you find Y? What? Yeah, Y is just going to be 2 times 5, which will give me 10. So guys, mathematically, it's not that difficult. But what's hard is matching up your sides. And you're going to have to remember these ratios, okay? A, square root of 3 times A, and 2A. And that's different from a 45, 45, 90. 45, 45, 90 is A, and the square root of 2 times A for the hypotenuse. Okay? Also, what should have been our longest side? Y. Why should Y be the longest side? It's the hypotenuse. When we calculated it, was Y the longest side? Bingo. What was the shortest side? The 5, right? Which is opposite the 30. Does that make sense? Yeah, so it works, okay? Always go back and check that. Guys, you can cross out this little expression thing because we're using a calculator for this chapter. Okay, moving on. The diagonal of a square has a length of 6. What is the perimeter of the square? What do I always do for these problems, peeps? Draw a picture. What am I drawing? A square. What do I know about squares? Okay, they're rhombuses and rectangles. What do I know about this figure? 4 90-degree angles. Let's put those in there. And 4 congruent sides. So let's put congruence marks on the sides. Okay? What did it give me?
A square.
Read the question again.
Diagonal of a square. The length of side.
It gave me the length of what?
A side.
No, it didn't give me the length of a side. It gave me a diagonal. So draw a diagonal. And how long was that diagonal? 6. So do you notice, because remember, this whole lesson was about what kind of shape?
Triangle.
Right triangles, right? Do you notice a right triangle now?
Yes.
All right, highlight one of them. Yours might be different than mine.
Oh, it is 45, 45.
Ah. Someone said 45, 45, 90. Why is this a 45, 45, 90? Okay, the diagonal cuts the 90s in half. But also, what do you notice about this triangle? Is it not isosceles? Okay, so don't these two have to be 45 degrees each? Beautiful. So we're given the hypotenuse though, right? So let's write down, we're dealing with 45, 45, and 90. What goes opposite the 45s? X, right? Because that's an unknown value. So we're going to put X and X. What's opposite the 90? 6, because that's your hypotenuse. Now, underneath that, do you guys agree it should be A, and what's the last one?
C.
Square root of 2 times A.
Didn't we do this one?
We did do this one. What's that? Yeah, go ahead. Which one of these can I solve? The 45, or the 90? The 90, because it only has one variable, only has A. So write 6 equals the square root of 2 times A. How do we solve this?
Divide square root by both sides.
Divide by the square root of 2. And it's 4.2. Now, it did not want the length of one of the sides. What did it want? What did it want? The perimeter. How do you, if you have one of the sides, how do you find the perimeter? Correct, because the square has all the same sides, right? So if this side is 4.2, we just take, okay, perimeter is going to be 4 times 4.2, which I believe is 16.8. Check me on that, please.
Multiple? Oh, never mind.
Did it give units?
No.
Then just put units.
But you multiply 4.2 by 4?
Yep, because there's 4 sides. Mm-hmm. And we know since it's a square, all those sides are going to be the same distance. Who said they don't get it? Go ahead. So once I found A, Amanda, I just found the length of one of the sides, right? And do you agree that perimeter would be the distance around the entire square? So how many sides are there? Each of the sides is 4.2, correct? So we just take 4.2, we multiply it by 4 to account for all 4 of the sides. Okay? Yeah. All right, let's do another one. Let's deal with an equilateral triangle that has an altitude of 5. Find the perimeter of the triangle. So, what is an equilateral triangle? All the sides are the same length. Very good. So let's draw a triangle with all the sides the same. What else do I know about equilateral triangles? They're equiangular. So what are all the angles? 60 degrees. Put that in there. What kind of example do you think this is going to be? It's going to be a 30, 60, 90. Okay, now check it out. What is an altitude? The height, right? So start at the top of your triangle and draw a line that goes down to the base. But what's so special about this line? It's a right angle with the base. And yes, Cody is correct. It will create 2 right triangles. Focus on one of them. It doesn't matter which one you pick. I'm going to focus on this one on the right. And it told me the altitude was how long? 5 units. So now you guys agreed this is a 30, 60, 90, correct? But it gave me the side that's opposite the 60. So this is my 30-degree angle, and this is my 90, correct? So what letter goes opposite the 30? You can put X there. It's also represented by what? What always goes opposite the 30 in a 30, 60, 90? Little a. Very good. So we're going to write 30, 60, and 90. In our case, we have X where 30 is. And we're going to represent that by A. Across from the 60 is 5. Do you guys agree? So we're going to put 5 here. How does that relate to little a? Square root of 3 times a. And then 90, just use another variable. What's another variable other than x? Y. Let's make 90 y. And how is y related to little a? It's going to be 2a. Very good. So now, which one of these three, if we were to put equal signs here, only has one variable? The 5 and the square root of 3 times a. So we can solve this one and get a. Okay? So let's solve it. It's 5 equals the square root of 3a. How do you solve for a? Divide by the square root of 3. And then plug it into your calculator. What's 5 divided by the square root of 3? 2.9? Yeah. But guys, I have to find the perimeter. And I'm going to tell you right now, you do not multiply this number by 3. Because what did we just find? We found a, which is the same as x. Do you guys agree? So you guys agree, we just found 2.9, which is this piece. But y is the length of a side. Do you guys agree? And what is y in regards to a?
2a.
What's 2 times 2.9? It's 5.8. So the length of one of the sides is 5.8. And the perimeter would be adding up all three of those sides. Do you agree? So we could take 5.8 and do what with it? Multiply by 3. Which I think is 17.4. Yes.
How do you find your x? Like
So x was equal to a, right? So once we solved the 60-degree side, right, the middle side for a, I plugged that in for x, right? So I knew, okay, now this is 2.9, so I can substitute that in here.
yeah, but I don't get like how's 30x?
Oh, because it's opposite the 30-degree angle. And then you don't have to use x if you don't want to. You can leave it as little a, okay? But I like to just use a variable in my problem, okay? Other questions? You sure? Okay, try the exit ticket. Try these two, and we'll go over them when you're done.